Hi you guys, we're going to be doing scatter plots and line of best fit for our set of notes today. So go ahead and take some time to actually plot this table down, the body length of a panda. We're going to talk about little pandas today. So the first is the age months, 1, 2, 3, 4, 5 months, and that actually represents our X value. And then we also have our body length, which is in inches, and those are 30 inches, 55, 80, 112, and 136. And that always represents our Y. So again, go ahead and take some time to write down that table and label what values are the X and Y. Then we're going to go ahead and actually make the scatter plot by plotting these points. So as you can see here, since this was the age is our X and then the body length is our month, our inches, we have a 1, our point actually that we plot would be a 1, 30. So I just want to review that with you guys so that we can actually go over here to our graph and actually create a scatter plot. So the whole point of actually creating a scatter plot, we need to title it. So you have to have a title, and that is our body length of a panda. So go ahead and title body length of a panda. Then we're going to title our y-axis, which is this one. And we are labeling it body length. And then we're going to make sure that we include our actual units of measure that it's actually in, which is inches, so that we know what we're talking about on that side. So we're going from 30 to 136. So I'm trying to figure out a number that I want to label this graph. And I think I'm just going to go by tens. So then we can go up all the way up to 136. Or actually, it should be allowed us to go above. And I am going to count by tens, however, I'm going to actually, just so I have more room, I'm going to actually only label the 20s. But I'm going to skip one, do a 20, and then 30, 40, 50, 60. If you guys count by tens, that's totally fine on your paper. I just don't have enough room to be writing on this. And then we can go ahead and actually stop once we get to the 140 mark, since I know what we're actually counting by. Okay. So then now, just make sure you guys are counting consistently and your spaces between those are also consistent. Now we're going to label our x-axis, which is down here, and we're going to label it age and months, because months is our quantity. That's what we're actually counting by. And now I'm going to just count these by 1 as well. So if I say 1, 2, 3, 4, 5. And again, you guys, I'm still counting by ones. I just went by twos on my paper, but just remember, like, you have 1 right here, and then it goes 2. So now I have my actual values labeled, so now I'm going to actually go ahead and make a scatter plot. So my first point, like I said, was 1, 30. So I'm going to go right here, put a dot. My next one is 2, 55. Go ahead and put a dot. As close as it can possibly be, you guys. It's totally fine. Number 3 is at 80. And then we have our number 4 is at 112. And then we have our number 5, which is at 136. Okay, so we should be good now. So now we have made our scatter plot. Check, we did number 1. Now we're going to draw the line of best fit. So we're basically trying to draw a line that's going to hit most of our data values. However, it doesn't have to hit all of them. So I'm going to start from the top and go from the bottom, trying to hit as many points as I can. You're not really wanting to try and curve it as much. If you guys can draw straighter lines, that's totally fine. You can kind of see it didn't really go through that dot until I drew the second one, which is totally fine. Okay, so I drew my line of best fit. Now, does the data show positive, negative, or no correlation? Well, my line happens to be going up, so it actually is a positive correlation. Now we're going to write an equation for the line of best fit using the following points. So I actually have you guys, I'm going to have you use specific points. So the 2 is right here, so 2, 55. And then I'm also having you use 5, 136. And again, I just determined that because that was my x value, I went and saw the x value in the actual x row, and then the 5 as well. The 5 was also here. So now using those points, we're going to go ahead and write an equation like we did in those previous notes using our slope and then using a point to find our y-intercept. So I'm going to label this x1, y1, x2, y2, and then we have our y's on top, so this is going to represent our m, our slope, 136 minus 55, and then we have 5 minus 2. So on top, with our 136 minus 55, we get 81. 5 minus 2, we get 3. And when we divide 81 by 3, we end up getting 27. So again, that's going to represent our m in our slope-intercept form equation. Or sorry, our y equals mx plus b. So we now need to figure out our b value. So I'm going to plug in, let's just pick one of the points. I think it's easier using the 2, 55 to plug in. So I'm going to use that as the y value equals my new slope right here of 27. And my x value is I'm going to pull from that point. Remember, you multiply. And again, you guys, I'm just plugging it into the y equals mx plus b formula. And then we're going to figure out what b value is. Well, 27 times 2, we get 54. And we still need to actually get b by itself. So I'm going to subtract 54 from both sides. And when I subtract 54, I end up getting b equals 1. Now I have all my important information. I have my slope and I have my y-intercept to put it into slope-intercept form. So your equation should always be have a y in it. Our new slope was 27. Always have an x in it, plus 1. This is our equation for our line of best fit. So the next thing that we're going to talk about, we're going to explain in words what our equation actually means. So I'm going to go ahead and write it from the previous slide. So I had y equals 27x plus 1. Okay, so now when I have my interpretation, we need to make sure what we're talking about. So we have 27 inches per month that a baby panda will grow. So again, how I knew that was 20 inches per month. Remember, you guys have your y, your change in your y over your change in your x. So when we look back here, our change in our y value was the body length in inches, and then our age in months. So remember, in order to put 27 as a fraction, we always have it over 1. So the y value, again, was our inches, and then our months were below here. So that's why it's 27 inches per month. That's how much a panda will grow. Now that our actual b, our y-intercept, is where the graph actually crosses the y-axis. So that means that at 0 months old, the baby panda, at 0 months, the panda is 1 inch. So that does, I mean, I don't know about just 1 inch, but it does make sense that when a baby panda or any baby is actually born, they're not 0 inches tall. So they're actually is going to be definitely inches. So at 0 months, the panda is 1 inch. So that may be in the womb. So some of these may or may not make sense, but that's just interpreting the actual equation into words. So now, how long would you expect an 8-month panda to be? So we need to plug this 8 months into our formula here, and we want to know, okay, well wait, which one does our 8 months represent? Which is it, x's or y's? Well, right here we can see it was on the bottom. Months were our x's, so I'm going to plug in this 8 into our x, and we're going to solve. So we need to do 27 times 8 plus 1. When we do 27 times 8, we get 216. We're going to add 1 to it, add that 1 inch to it, and we get a 217-inch panda. So I'm going to go ahead and write our final answer as a sentence. And my final sentence says the panda would be 217 inches long after 8 months. So these are the sentences I'll be looking for, you guys, making sure you're getting it, and I will check in with you guys tomorrow. Thanks.